Assalamu alaikum. I'm your teacher Rehan Tareen and I'm back here with a new lecture of physics class 9th. Chapter number 1, and it will be the last topic, 1.7 significant figures. Before this we had a topic of 1.6 measuring instruments, in which I explained three of the measuring instruments including measuring tape, meter rule and vernier caliper. I told you that these are some practical topics and can't be explained on the board, so I skipped the rest of the topics, which included screw gauge, stopwatches, and the beam balances, etc. So those are very easy topics. If you read in the book, you will understand easily. I can't explain them here because they are some practical topics and they can't be taught on the board. So we'll be moving further on topic 1.7. We have significant figures. First of all, we'll be having a small detail. I have measured 3 points here and 2 points here. So we'll having a small detail of these 5 points. Then we'll be coming to our topic significant figures. In your daily routine, in your daily life, you have been to your school or at home, you may have seen that if 1% counts or measures something, measures the length of something. For example, if someone measures the length of something 10 centimeters, A person measures it 10 centimeters, and B person measures the same as 11 centimeters. So there has been a difference of 1 centimeter. Why has this difference arisen? Of the same thing, the measurement has been different. Why? Because I've mentioned some points here. Maybe the quality of the instrument is not of the standard. In vernier caliper, I told you we have find zero errors because of the quality of the instrument. Rather than exchanging the instrument, we use the zero corrections there. But here, the quality of instrument depends upon the reading of the people, that how much that what observations have they made. Number one is quality of instruments. Number two is skill of the observer. Now, what does the skill of the observer means? That the person who is observing the measurement, how much skill does he have in the observing the measurements? For example, can he accurately measure? Does he know that from which angle to we have to measure the measurement? So I'll give you the example of the measuring tape or the meter rule, that we have to measure, we have to look into it vertically, then we can find out the actual reading. But if you look into it horizontally, you will not get the exact reading. So skill of the observers. And number three is number of the observations made. You may have seen that we always have an average in something. For example, if in your class the student's height is about 5 feet 1 inch, 5 feet 2 inch, 5 feet 3 inch, 5 feet 4 inch, and the maximum student has a height of 5 feet 2 inch. So it has an average of 5 feet 2 inch. So the class will be given as the average height will be 5.2 inch, because mostly the student has the same height of 5.2 inch. If we have many readings A, B, C, D, E, F, G, mostly the readings are coming between 11, 12, 11 and 12, 11, 11, 10, 11, 11. 11 is repeating again and again, so we'll consider that 11 is the exact measurement, because mostly the observations are having the reading of 11 centimeters. Now, I'll be coming to the topic that in significant figures, if we take a measurement of anything, we'll find accurate digit and doubtful digit. There are two types of digits. One will be accurate digit and one will be the doubtful digit. For example, if someone has the person A has the measurement of anything that is 75 meters of a road or of a wall of a ground. For example, he has the length which distance which is equal to 75 meters. So here the 7 will be accurate digit and 5 will be doubtful digit. Why? Because A person has taken the measurement at equal to 75 meters. B takes the measurement which is 74 meters. C takes the measurement which is 76 meters. D takes the measurement which is again equal to 74 meters. So here 7 has been repeated by mostly. 7 can't be changed because it's the exact value and it's known that it is coming in 70. So 7 will be the accurate digit. 5 has been changed. It's varying from one observation to other. For example, here it is 5, 75, 5, 74, 4, 76, 6 and then 74, 4. So 5 has been changing 4, 6 and 4. That's why it will be known as doubtful digit. Doubtful digit means that we still have a doubt in it. It is not clear that exactly is it the same measurement or it can be changed. So these were the accurate digits, doubtful digits, and what are the situations? How can we find out the significant figures? Now, what are the rules of finding out the significant figures? For example, number point one is that non-zero digits are always significant. It says that there is no decimal points in a number and all the numbers which are there are non-zero. I have written an example here: 234, 2, 3 and 4. There is no decimal point between them, so this all will be a significant figure. Number 2 is 0 between two significant figures are also significant. It says that if we have two significant figures, here we said that all non-zero digits are significant, so it is also significant. This 2 is also significant. This point says zeros between two significant figures. Here is one significant figure, two significant figure, and what are the zeros here? These two zeros will also be significant. Zeros between two significant figures will also be significant. Point 3 says final or ending zeros on the right are significant. It says that if we have a measurement of decimal, for example 0.370, 0.370, so the zeros on the right side here, this zero will always be significant. Or it says final or ending zeros on the right side is significant. It can also be written that a simple value of 200. All the zeros on the right side shows the values, because if we remove them, the number will be 2. There is a lot of difference between number 2 and 200. So these are always significant. It may be in decimal or without decimal. Number 4 point says zeros on the left of the decimal points are non-significant. You may have seen that sometimes we write 0.78 or sometimes we write 0.78. There is no difference between them. If we write the 0, no matter. If we don't write, no matter. We will be looking at the point because before point 0 must be there. 0 is there. There is no point of confusion here. So zeros on the left of the decimal point are non-significant. If there are zeros on the left side of the decimal, so then they will be non-significant, because if you write them, no matter. If you don't write them, also no matter. The last point is having a special case. It says that whole numbers that end in one or more zero may be or may not be significant. It has a special case which is not described in our book in detail. It is just said that in whole numbers, if we have the whole number ending with 0, 1 or more than 1 zeros, so it may be significant or may not be significant. So this was our topic, significant figures. Hopefully you may have understand it.